exerted by Earth on some another body. The property of a body to resist changes. Gravitational mass of a body is a factor. It has a period of rotation of 24 hours, the period of revolution of a planet around the sun. Hello students, the last session on the chapter Gravitation, where I will focus on three beautiful laws formulated by Kepler, the so-called Keplers Laws of planetary motion. Now, in my previous session, we discussed about satellites. We told they are celestial bodies. They revolve around planets in specific orbits. They have orbital velocity. And they are basically used for forecasting the weather, remote sensing, communication, spy satellites. And we also concluded by speaking about geostationary satellites, which revolve around the Earth in the same direction and the same angular velocity as that of the Earth. It has a period of rotation of 24 hours, exactly the same as that of the Earth. It is posed at a height of 36,000 kilometers from the surface of the Earth, and finally its orbital velocity is 3 kilometers per second. Now, continuing further, we have something called remote sensing satellites. So now I will be talking about remote sensing satellites. We say these are the satellites which is used to study the natural resources of the Earth, to have an understanding of the natural resources of the Earth, such as forest depositories, forest glooms, forest wealth, water resources, underwater findings, mineral deposits, agricultural crops, etc. And hence, it has been named as remote sensing satellites, to sense the hidden, remoted wealth, forest wealth, water resources, mineral deposits, agricultural crops, etc. And spy satellites are a type of remote sensing satellites used for defense purpose. So as I told, unfortunately, Indians have not been able to develop one defense satellite. Hope one of you will take it up. Good. My next topic here is to speak about inertial mass. Inertial mass. We have already understood about inertia in our previous chapter. We told it is the property of a body to resist changes. Disability of a body to change its position by itself. And we told mass is a measure of inertia. Now, what is this inertial mass? We say inertial mass is a mathematical factor. Keep in mind, inertial mass is a mathematical factor. It is a ratio of external force applied. External force applied on the body to the magnitude of acceleration produced in it. So inertial mass is F divided by A. F is the external force applied, A acceleration caused, and that ratio is called inertial mass. And this is a factor which actually measures the mass or the inertia of a body. If the mass is very, very small, small force is required to change the position of a body. Huge boulder, mass is huge, then the external force applied is also very large. Therefore, this is a factor which is actually measuring the inertia of the body. Now we study something called gravitational mass. Gravitational mass of a body is a factor, or exclusively I say, is that mass which determines the gravitational force exerted by the earth on the body. So, the gravitational mass of a body is the mass which determines the force of attraction, the gravitational force of attraction exerted by the earth on a body. And it is given by this expression. This is from Newton's law. And please to understand, this mass has no role in inertia. Gravitational mass will simply measure the gravitational force of attraction exerted by earth on some another body. It doesn't have any role in accepting the inertia of the body. It is the measure of force of attraction. So in the examination, usually for 2 marks, they ask a question to differentiate between gravitational mass and inertial mass. Now this is an assignment for you all. I have already spoken about this when I have taught Newton's third law, when we try to become familiar with action and reaction, where I've clearly told absence of reaction is what you call weightlessness. A common phenomenon experienced when we are in a lift, common phenomenon experienced by astronauts in a spacecraft. Just have a look at that. This should be an issue of pondering for you all. When I say just have a look, go to the textbook, try to understand the phenomenons. The last one, but very, very important, repeated question in the exam for 5 marks. This is one of the questions which is a favorite of any question paper setter. Something we say, Keplers laws of planetary motion. 3 laws formulated by Johannes Kepler to explain planetary motion, motion of planets. The moment people discarded geocentric theory and believed in the existence and prominence of heliocentric system of the universe, immediately a scientist by name Kepler makes an attempt to explain the nature of the motion of planets around the sun. And the consequence is the 3 laws formulated by Kepler. The first law says, very important, all planets move around the sun in elliptical orbits. Shape of the orbits in which the planets revolve is an ellipse. Purposefully, I have not completed the ellipse. So the nature of the orbit is something like this, which is an ellipse. So very clearly, Kepler's first law says, each and every planet revolves around the sun in an orbit which is elliptical in nature, and the sun is one of the focus. Focus andreno, something which is highlighted, something which is prominent, which is eminent. So sun is the focus, the prominent point of that elliptical orbit, the highlighted point of the elliptical orbit. So very clearly, the first law of Kepler says, all planets, every planet revolves around the sun in elliptical orbits, sun being the focus of that elliptical orbit. So according to Kepler's first law, the path of the planets around the sun is elliptical, sun being the focus of that elliptical orbit. Now, The second law, it says an imaginary line, mathematically, this imaginary line is called radius vector. Some line drawn from the sun to the planet. If you are drawing an imaginary line from the sun to the planet, then it covers equal areas in equal intervals of time. Therefore, the second law is also called the law of areas. An imaginary line, a radius vector which is drawn from the sun to the planet, covers equal areas in equal intervals of time. Meaning to say, if a line is drawn from the center of the planet to the center of the sun, line drawn from the center of the planet to the center of the sun, the line would cover equal areas in equal intervals of time. See, meaning to say, if the planet takes time t1 to move from A to B and takes time t2 to move from C to D, T1 to move from A to B, T2 to move from C to D, then T1 has to be equal to T2, time taken by the planet to move from A to B should be the same as the time taken by it to move from the point C to D. Also meaning to say, the area ABS is equal to SCD, equal intervals of time in equal areas covered. Third one, this is called the law of orbits. It says the squares of period of revolution, if t is the period of revolution, the squares of period of revolution of a planet around the sun is proportional to cube of their mean distances. So t square is always proportional to a cube. Idna semi-major axis intlu karitivi. If t is the period of revolution of a planet and a is the mean distance of the planet from the sun, t square is proportional to a cube. Law of orbits is the first law, is called law of orbits. So this is the first. Second law is called the law of areas. Third law, the law of time period. So all planets revolves around the sun in elliptical orbits. Sun is the focus of the orbit. Second, a line drawn from the center of the planet to the center of the sun covers equal areas in equal intervals of time. Third, the squares of the period of revolution of a planet around the sun is proportional to the cube of the mean distances. And what is a planet? It is a non-luminous celestial body revolving around the sun. So, dear students, this completes my discussion on gravitation. Newton's law we studied. Variation of acceleration due to gravity we studied. Satellites we studied. Kepler's laws we studied. The next session, I come back with work power energy. Until then, briefly, thoroughly understand this chapter. Have a nice day. Thank you.